Welcome to Bestech Clean Energy's presentation on waste-to-energy incineration. Bestech Clean Energy is a developer that specializes in renewable energy and waste-to-energy. We offer three types of renewable energy plants: waste-to-energy incineration, waste-to-energy biomass gasification, and commercial solar systems. Our presentation today will be on our waste-to-energy incineration plant. We have the capability to design, develop, build, and operate waste-to-energy plants for you. In this presentation we will go through the various requirements and steps needed to go from design to an actual working waste-to-energy plant. There are three primary methods of handling municipal solid waste or MSW. The first is landfilling. Landfilling has been the most common method of disposing of waste for many years. However, landfills have become both overburdened and sources of pollution. Landfills can cause ground contamination and air pollution from the decaying solid waste. Second method is composting or digesting the solid waste. Composting or digesting uses bacteria to allow the solid waste to decay and give off gas, primarily methane, which can be used to make energy. Composting or digesting the waste is limited in the types of waste that can be processed. The third method is incineration or burning of the waste. There are different methods of waste burning, such as incineration, gasification, and pyrolysis. Gasification and pyrolysis create synthetic gas and burn that gas to make electricity. Incineration actually combusts the MSW materials directly, to make heat. The heat from the process is then used to make electricity. There are many different types of incinerators in use all over the world. One of the most efficient types of incinerators is a moving grate incinerator. Municipal solid waste or MSW is the name given to the solid waste collected from a given area. It includes household waste, commercial waste, construction waste, and biomass waste. Within the MSW materials, you can have recyclables, organic waste, inorganic waste, plastic, glass, metals, and hazardous waste. Untreated MSW can leach into the ground and cause water pollution. It can also create air pollution from the methane and other gases that it gives off as it decays. A modern incinerator plant, with state-of-the-art treating and filtering systems, can capture these harmful gases and liquids before they can be released into the environment. There are advantages of waste-to-energy incineration over other methods of waste disposal. The first benefit is the land usage needed for each type of solid waste handling. Landfilling can take large amounts of land space, whereas composting and incineration do not. The initial investment in incineration is higher than biodigesting or landfilling. However, potential environmental problems can make landfilling of the waste actually cost more than the initial investment in the landfill. Operating costs for an MSW landfill are lowest of the three methods. But again, potential environmental problems can make operating landfills much more expensive. Biodigesting and incineration operating costs are fairly close to each other. The biggest advantage of waste-to-energy incineration is that it can reduce the volume of the waste by as much as 90%. Properly treated, the bottom ash from the process can be safely disposed of or used in construction. So, what are the benefits of incineration? Incineration is capable of processing a wide variety of feedstocks, including municipal solid waste, MSW. Using MSW as a feedstock source to create energy prevents an equivalent amount of fossil fuels, such as coal or natural gas, from being burned to make that same energy. Incineration of waste can be considered a renewable energy source. Waste materials are continuously being produced. Incineration plants can be scaled in size, based upon the availability of the waste materials. The facility size is determined by the amount of waste that can be processed. Emissions from the incineration process are passed through multiple cleaning processes to assure that emissions from the plant are cleaned of hazardous materials. Incineration facilities can be constructed close to the participating communities that they will be serving. An incineration plant would mean new permanent jobs needed to operate the incineration facility, as well as construction jobs needed to build the plant. Here are examples of actual operating incineration plants using the design that Bestech Clean Energy is proposing to you today. Each plant is customized to suit the customer's needs. This is a diagram and overview of our incineration system. There are many steps and stages that the solid waste goes through before it is turned into electricity. The first is collection and transportation to the waste-to-energy facility. Waste is collected from a variety of sources including households, businesses, and municipalities. We will work with your current waste collection and hauling companies to design a plan that works best for us and them. An automated scale will weigh and record the truck weights, both incoming and outgoing, to determine the weight of the solid waste being processed through the plant. When the waste arrives at the plant, it goes through the receiving and storage process. The trucks delivering the waste to the plant will dump the waste into a large waste pit. This allows the trucks to quickly unload their waste in a short amount of time. Air curtains, negative pressure in the building, and deodorant sprays will keep any odors contained within the plant. During the storage process, the waste is sorted, dried, and shredded to maintain good heat values of the waste being processed through the incinerator. Items in the waste that should not be processed through the incinerator are removed during the sorting process. Metals, glass, recyclables, bulk waste, and hazardous waste items are removed. The next stage is the actual incineration system. The stored waste materials, or refuse-derived fuel or RDF as it is known, are burned in the incinerator to make heat to power a boiler, which in turn makes steam. The heat utilization system uses the steam to power steam turbine generators to produce electricity. The flue gas treatment system removes all harmful gases or particulates coming from the incinerator through various filtering and chemical processes. It ensures that no harmful materials will be in the plant emissions. The ash heating and treating system prepares the ash materials for use in construction or for clean disposal. The leachate treating system filters and treats the liquids that were extracted from the municipal solid waste materials in the storage pit. It neutralizes the liquids and recycles them back for use in the boiler. The sewage treatment system takes the liquids that were extracted from the waste materials during the sorting and drying process, filters and cleans them. It then recycles them back into the process. Here is what happens with the municipal solid waste when it arrives at the waste-to-energy plant. Waste trucks are weighed on the weigh bridge before entering the plant. There is a scale so trucks can be weighed automatically as they arrive at the facility, both incoming and outgoing. Each truck's number will be recognized by a camera snapshot automatically. This will allow the scale to be unattended. All the waste weighing data will be uploaded to the plant control system. The MSW tipping hall has air curtains and negative pressure in the building prevent odor emission. The doors open automatically to have fast unloading. Waste is unloaded and stored in the waste pit. The waste pit will store 5 to 7 days of municipal solid waste. There will be a semi-automatic grab crane to control the flow of the waste materials in the storage pit. The grab crane is equipped with an anti-collision system to avoid wall or other damage within the waste pit. The grab crane is operated from the control room. The control room is designed to give the operator a full view of the plant. An intelligent management system is used for the stocking and feeding process to ensure effective combustion and maximum heating value in the incinerator. Here are the processing steps that the municipal solid waste materials go through prior to incineration. Pre-treatment consists of mechanical sorting technology and RDF fuel granulation technology. The first step is coarse shredding. Raw waste will be shredded and crushed into a size less than or equal to 250 mm to further sort it. The next step is ferrous metals removal. The iron-based ferrous or magnetic materials in the MSW will be sorted out to capture metal in the MSW. Next is inert materials screening and sorting. Inert substances, non-combustibles, such as glass, and non-ferrous metals will be screened out. The next step is blown air separation. Most of the lighter recyclable substances will be sorted out before incineration. After recyclable substances are removed, fine shredding takes place. Combustibles will be crushed into a size of 80 mm or less, for consistent processing through the incinerator. Finally, the materials will go into product storage to await processing through the incinerator. At this point, the materials are referred to as refuse-derived fuel or RDF. Here is a diagram of the incineration process and ash handling systems, along with the operating parameters of the system. The incineration process can be divided into stages: the feeding system, the hydraulic transmission system, the ignition system, the incineration system, the air combustion system, and the bottom ash handling system. This illustration shows you the different types of moving grate incinerators in use all over the world today. As part of the design and development process, we will analyze your solid waste to select the best type of incinerator that will work for you. The selection of the incinerator is customized for each customer and plant. Some of the most common moving grate incinerators are German Martin, Japan Mitsubishi, Denmark Volland, Belgian Sigurs, Hitachi Zosen, and German Steinmuller. Some of the advantages of moving grate incinerators are less pre-treatment of the materials, and better heat value from the municipal solid waste materials when processing the solid waste. High combustion temperature and process stability. High thermal efficiency. High level of process automation. Easy to maintain and low process costs. Clean process emissions. Incinerator heat recovery and power generation systems can be vertical or horizontal. A vertical system takes up less space when available spacing is a consideration. Vertical incineration systems use some of the high-pressure steam from the process for self-cleaning and maintenance. Maintenance costs are more often higher with vertical systems than with horizontal incineration systems. Horizontal incinerator systems require more space and can cost more than vertical systems. They use electrodes in the process to keep surfaces clean of ash during the incineration process. Power generation is achieved by the use of steam turbine generators. Our system offers efficient power generation through improved heat recovery, improved steam turbine efficiency, and reduced plant power consumption. Here is a diagram of the flue gas treatment system. The system is customized based upon the types of gases coming from the incineration process. As you can see, it is a comprehensive cleaning process designed to capture any harmful gases coming from the incineration of the waste. Depending upon the makeup of your MSW, the treatment process is designed specifically to meet your needs. Each stage in the gas cleaning process is designed to remove different types of possibly harmful emissions. The gas treatment system meets or exceeds USA and European emission standards. This illustrates the flow and treatment of the ash materials before leaving the facility. The ash materials are neutralized and can be safely disposed of, or used in construction. Here are images of the leachate or liquid treatment system. This ensures that the moisture coming from the MSW materials is also thoroughly cleaned. The process uses biochemistry in a membrane bioreactor, MRB, to remove possibly harmful materials from the leachate. Any methane produced from the anaerobic reaction of the leachate is sent back through the incinerator to be combusted. Here is a diagram of the odor control system for our incineration process. As you can see, great care is taken to make sure that no odors escape into the surrounding area. Air curtains, deodorant sprays, and negative pressures are used to keep any odors within the building. If the incinerator and boiler are not in operation, an active carbon cleaning deodorant device is used. Here are the typical operating system parameters for our incineration process. Some of the operating parameters will vary according to the waste volumes, waste makeup, and the size of the plant. Here are some of the typical customer requirements analysis done during the design process. We look at environmental benefits requirements and social benefits requirements. We also determine the flue gas emissions requirements, water resource recycling utilization, and bottom ash use or ash disposal requirements. We also take into consideration safety and reliability requirements of the project, as well as the economic forecasts for the project. Our plants are designed to operate more than 8,000 hours per year and have a life of over 30 years. They are very efficient in thermal conversion and power generation. Other considerations to be taken into account are waste collection capacity, land or site location and surrounding area, makeup of the solid waste materials, water conditions, and interconnection grid requirements. Project studies will be done to determine all of these factors. Here are plant design considerations. They include boiler design, electric control system design, architectural design, waste drying, sorting, and shredding, and the water treatment method to be used. There is a customer project design plan for each customer to meet their needs. Bestech Clean Energy. Bringing the best available incineration technology to meet your needs today and for your future waste handling demands. Our contact information is below.